Hello, my name is Samantha, and welcome to our Embedded Systems Workshop curriculum. Through this course, you will learn relevant programming, electrical, and mechanical concepts through circuit building and embedded systems applications. Let's get started.
We'll go ahead and start the embedded systems. And I'm sharing my screen, right? Yeah. Cool. Alrighty, so hello, you guys. Today we're going to start the embedded system workshop. So today is basically just an introduction to what embedded are and Arduino and the components of Arduino. So definitely really closely related to robotics. So that's why we're doing the embedded systems and course expectations. So in the future, once we get the kits, definitely be good to have your cams on so you can see the Arduino kits and what you're building, so we can kind of help each other or cooperate that way. And today we're just gonna go through some basic program info. And I think most of you have the GitHub repository already for embedded systems, but if you don't, we'll be sure to set you up with that. And the registration form, if you haven't filled that out, definitely do that so we just know who's planning to do workshops. And we'll also let you know all the contact info and the way we will communicate. And yeah, we'll just do good introduction as to what Arduino and everything you'll be needing and just the basics. So basic program info, embedded systems, we'll go through what embedded systems exactly are in a bit. And the meets will be every Friday from 4 to 5. So just going to be virtual through Google Meet. And we'll be doing this up until early May, so just a few months. And Stefan and I will be kind of leading the Arduino and those workshops. So all you'll really need to be able to actually do it is a computer with internet, a GitHub account, and the starter kit, which is $37 on Amazon. But if there's any kind of reason, or if you do need any sort of help with paying for it, you can let us know through email or just contact one of us. And we'll probably be able to get it to you through, I think, the foundation. But yeah, the main part is just the starter kit, which has everything you need to actually build your Arduino and do all the cool workshops. And main purpose for starting this embedded systems workshop is because of all the restrictions here in San Diego with COVID-19, we can't do in-person competitions or meetings. And especially because of social distancing restrictions, usually we'd be in a room just all together working on one robot, but with our personal kits, we can remotely kind of practice some robotic skills like programming and other mechanical and electrical skills, and we can all do that through Arduino, which is really cool. And I'm pretty sure all of you guys have joined the Discord, but if you haven't, that's our Discord invite link. And definitely good to know our email in case you have any sorts of questions. And also follow us on Instagram if you haven't, which is CCA Girls Who Code. And just all your information if you ever want to contact Girls Who Code, or if you have any robotics questions as well. And our schedule is kind of like a weekly-ish basis, and right now it's just tentative, so not going to be this isn't final, but kind of just a general plan for what we have. And you can take a look at it in the link there, which is in the slides. And for our Arduino workshop topics, basically we have blinking LEDs. So you might have seen this before, or you might be familiar with the LEDs. I think if you took Exploring Computer Science, you've done that. But LEDs are a really cool little project to do with Arduino, and also buttons. We'll be kind of inputting code, and we'll be able to play with that. And there's all sorts of different cool sensors and things that come with the kit to try out. Oh, like servos, sensors, all sorts of really cool things. And yeah, earlier I talked about the GitHub repository, and I know most of you have done that already with forking it, but if you haven't, definitely let us know and we'll help you out with that. And the GitHub repository is basically kind of has the starter code and a bunch of resources. And right now you don't need the Arduino IDE, but once you get the kits, you definitely want to download the Arduino IDE. That way you'll be able to kind of plug it into the board from your computer, and you can upload your code. So that way you can actually implement projects like lighting up the LED or playing with the sensors. And if you haven't already, please fill out the registration form, and this way we'll just be able to keep track with the kits and who is doing the workshops and everything. And now we'll just be doing an intro to Arduino, so all just ties in with what we do in robotics and robotics meetings, where we practice like mechanical skills and programming skills. So perfect way to kind of remotely do robotics and tying into the embedded systems. So embedded systems, basically just a computer system that has a specific function. So computer system basically just has processor, memory, and an input-output system. And some examples of embedded systems are mobile phones, which you guys probably all have, video game consoles, digital cameras, GPS, and a lot more. And some applications of embedded systems are like microwaves and all different sorts of technologies. And for Arduino, I think we'll have Stefan kind of talk about the more technical mechanical things here. Oh wait, Stefan, I think you are muted.
So it's programmed using either C or C++. And the great thing about Arduino is it's open source. There's many Arduino compatible and also Arduino derived boards out there. And another great thing about it being open source is anyone can develop add-ons or say modules or what have you for it. So now here's the question of what is on an Arduino board. So you can see we've got a USB plug, which is how you input the code. You have a power supply, which, by the way, the USB plug will also provide power given that you've plugged it into, say, a computer or whatever. And there's the actual controller on it. Then we have all these pins. Some pins provide power. Some pins can be used to either take inputs or provide an output. Then we have our ground pins. We have digital input or output pins, and we also have analog pins. The difference between digital and analog is that digital is either on or off. Analog is a range of values. So then getting into the next question, what is C? C is a very popular programming language. It's used for quite a few things, such as developing embedded systems, desktop applications, operating systems like Windows, compilers, and of course, open source software. And here is a nowhere near exhaustive list of sensors that you can use with Arduino. For instance, we have a barometer, which measures air pressure. We have an auto-flashing LED. We have a gas sensor, an infrared receiver, an ultrasonic sensor, a humidity and temperature sensor. You get the picture. And this is just a small sample of the huge number of sensors and other modules that have been developed for Arduino.
And what's in the kit? So for the starter kit, that will have you guys use some basic parts. There's like a lot of long words that obviously we don't need to remember any exact terms, but some parts are the breadboard. So that's the like basic kind of part. I'll pull up a picture real quick so you guys can see, because breadboard doesn't really sound like some kind of robot term, but basically here we have the link to the kit, and the breadboard is basically this long place where we can put a lot of the wires and resistors in. And yeah, this is the link to the kit. It's $37 and it includes like a bunch of different sensors and parts. So everything is just in here. Also #1 bestseller. And yeah, there's a ton of cool things in here. And going back to the parts list, yeah, there's a ton of jumper wires, motors, temperature, humidity modules, all really cool things to play with. And the LEDs are probably my favorite because it has all the different colors and you can do really cool like light shows with the LEDs, or just mini light shows. But yeah, bunch of cool parts. And necessities, we'll pass on to Stefan.
All right, so the necessities to run an Arduino, you need the Arduino, of course. Without that, you're not going anywhere. You need the USB cable, which is used to upload the code from your computer to the Arduino and also provide power. A 9-volt battery, which is not truly a necessity, but you need it to power the Arduino when you don't want it to be connected to your computer. And lastly, jumper wires. Jumper wires are simply just wires that are used to connect different parts of, say, different Arduino board, different pins of the Arduino board to different, say, sensors and what have you. And we have 3 different types of jumper wires, which we'll get into in a minute. There are male to female, female to female, and then male to male. We'll talk about those in a bit. So here we have 3 kinds of wires. Male to female. The male to female has 2 types of pins. So we have 2 types of pins on these wires. A male end, which has a pin, and the female end, which has a socket that a pin fits into. The 3 kinds of wires are male to female, which have both a male end and a female end. The female to female, which has 2 female ends, and the male to male, which has 2 male ends. Another critical part of your Arduino is knowing how to use the breadboards. If you're wondering how they got the name breadboards, it's because in the past they were often actual breadboards. So knowing how to use a breadboard here, we have 2 vertical strips on either side of the breadboard. And we have many rows of horizontal strips here. So the 2 vertical strips on either side go all along the side of the board, and but they do not cross the middle divider. So if you want to link the 2, you'll have to run a jumper wire between them. Same story with the horizontal ones. They run along the width of the breadboard. Once again, they do not cross the middle divider. Here's one of the thousands of things you can do with Arduino is use lights, or LED lights. Here we have an example with a red light. So the LED will have 2 pins, the anode and the cathode. The anode is your input pin, where you connect your power source to. The cathode is the output pin, which connects to which would be the negative terminal. The positive or anode pin is always the longer of the 2. Do not mix them up, or you will probably destroy your LED. Another important part of Arduino is resistors. Resistors simply slow the electric current and can be used to control where current goes and how much current goes somewhere. By the way, if you're wondering why you need a resistor, so we saw a resistor in that LED picture. If you're wondering what happens if you run that LED without a resistor, you're probably gonna get a blown bulb, just because of the amount of current going through it. Resistance is measured in ohms, which is depicted using the omega symbol, and the resistor's value is is indicated by either a 4 or 5 band code, which we see here. On a 4 band code here, for instance, this one in this case is 37,000 ohms plus or minus 5%. So we see the first yellow band is 4, 7, and then we have 7 times 1,000, so 47,000 ohms. And then we also have potentiometers, which are simply a resistor that you can change the resistance of on demand. So here's a potentiometer. You can control how much resistance is applied by twisting the knob. And this is useful for adjusting how much current something gets on demand, like, say, the brightness of a light or a screen. And for the purposes of these workshops, we're going to use the potentiometer to adjust the brightness of the LED screen. And here is the LCD screen. A liquid crystal display is a screen that's used in basically anything that has a screen nowadays. Your TVs probably have them. pretty much all your mobile phones have them. In this case, the liquid crystal display that we're using will only be able to display images, or actually will only be able to display letters and numbers on a 16 by 2 grid. So we have 16 characters across and then 2 down, so 32 total spaces. And we have all the pins that will connect to it, and then we'll go into much more detail of those as to what all those pins mean later on in a workshop dedicated to the LCD screens. Another thing that's commonly used with Arduino are servos and motors. And what they simply do is take electrical energy and convert it into rotational motion. A servo, which is on the left here, can only rotate within a certain range. Like these particular servos are designed to rotate between 0 and 180 degrees. A motor, meanwhile, is able to rotate continuously in either direction. And on the right here, we have a particularly beefy motor. The motors in the kits are nowhere near that big and nowhere near that powerful. An Arduino would probably burn itself out if it tried to run one of those.
Mm-hmm.
And here's another cool little sensor. It's called the ultrasonic sensor. What it does is it uses sound to measure distance. Basically, it sends out a sound wave because the speed of sound, of course, is not instant. Not even the speed of light is instant. It sends out a sound wave and measures the time it takes for the wave to return to calculate distance. Here's another interesting one. This is a temperature or humidity module, which is a humidity sensor and a thermal resistor to measure the temperature and the humidity of the surrounding air, where the signal can then be interpreted.
I think in the LCD, yeah, LCD.
We have an LCD that is also being displayed here.
And I think Stefan made a heartbeat sensor using the LCD as well.
Yeah, I have made a heartbeat monitor using the LCD screen before.
Yeah, I think sometime you should definitely show the sensors, because that's really cool. Oh yeah. And that is the end of the intro to Arduino and embedded systems. But yeah, if you guys had any questions about anything, please let us know, because Arduino is going to be definitely a huge part of everything. And
thank you, Sarah and Stefan, for helping host this. They did a great job teaching today. So today we went over. I'll send the slides out after the workshop in the email. But today we went over introduction of components, what you can use Arduino for, what kind of are embedded systems. I'm going to take over the presentation for a bit. Just so we can kind of talk about GitHub and what we'll be doing next week. So you saw this on the slides, but the two things that you'll need for this are a GitHub account and the Arduino IDE. So we're going to use this GitHub repository to show starter code. So what that means is that if there's any resources, any descriptions of parts or images, we'll put them in this repository. So what you'll need to do is make a fork of it, and there's already some people that have. We'll go over how to do this in detail next week, but if you don't already, please make a GitHub account and locate this, and there will be a link to it in the slide. Otherwise, if there's anything that Sarah and Stefan want to add, either about the course or things of note, please do so. I think we've covered all that we meant to